Hello friends, I am Dr. Prof.Chishty and I am teaching physics to BSc third year students. My today's topic is selection rule or the transition rule. Now we know that when an electron jumps from the higher to the lower orbit or lower to the higher orbit, then it should follow certain rules. Electrons are following certain rules. Those rules are called as the selection rules or the transition rules. Electron may jump from higher to the first orbit, or when it gains the energy it may jump from the lower to the higher orbits. So first rule is that the change in spin quantum number, that is delta S, should be equal to 0. It should be equal to 0. It means that when there is electron, the value of S is either plus or minus half. When there is one electron having the spin in one direction, another in the spin in the another direction, then for one direction it is plus half and for another direction it is minus half. So change here, delta S will be final minus initial, that is equal to minus half, it will give you minus 1, and this is not allowed. Delta S is minus half, means it is forbidden. But when I see that when S1 is half, S2 is also half, then delta S is equal to half minus half, that is delta S is equal to 0. This is the allowed transition. So first rule is that the change in the spin quantum number, delta S change, should be equal to 0. Now come to the second rule. Second rule states that the change in magnetic quantum number or the azimuthal quantum number, magnetic azimuthal quantum number or the orbital quantum number, change in orbital or azimuthal quantum number should be delta L should be equal to plus or minus 1. Delta L should be equal to plus or minus 1. We know that the value of L will vary from 0, 1, 2, 3 and so on. It means that there are orbits S, P, D and F, corresponding orbits. When means delta L should be equal to plus or minus 1, means the electron can jump when I take the S and P, that is 1 minus 0, delta L here is plus 1. When I take P to D, that is 2 minus 1, it is also plus 1, delta L is plus 1. When I take D to F, it is 3 minus 2, it is also plus 1. So these are the allowed stages. Vice versa is also true. Electron may jump from the P to S, that is 0 minus 1, it is minus 1, or D to P, that is 1 minus 2, that is equal to minus 1, or F to D, that is 2 minus 3 equal to minus 1. So value of delta L should be plus 1 or minus 1. Those are the allowed transitions. Now what are forbidden transitions? For the forbidden transition, we say that an electron cannot jump from S to D. Why? Because here I take 2 minus 0, it is 2, and this is forbidden. It is forbidden or not allowed, or it is not allowed. From F to P, not allowed. D to S, not allowed. Means jump is not allowed. When an electron can jump from S to P, P to D, D to F, these are the allowed stages where the value of delta L should be plus 1 or minus 1. So these are the two conditions, and if I take the magnetic quantum number, that is delta ML, it should be equal to 0 or plus or minus 1 for the allowed transitions. Similarly, delta Mj it should be equal to 0 or plus or minus 1. So when these conditions are satisfied, we say that these are the transition rules or the selection rules for the transition of the electron. Now when we study about the Laporte forbidden and Laporte allowed stages, then Laporte forbidden or Laporte allowed stages, then we have to study about the Girat and ungirat system, means Girat and ungirat. What are Girat and what are ungirat? Here you have to study about the center of symmetry. Center of symmetry. Suppose here there is a center point, and if we travel plus 1 in this direction from the center, then we should travel oppositely also plus 1. When we go plus 1 in the upward from the center, plus 1 lower in the center, or it may be plus 2 to the right, plus 2 to the left, plus 3, plus 4, minus 2, minus 1, minus 1, minus 1, minus 2, minus, means the same position should be obtained. It is known as the center of symmetry. When the center of symmetry is obeyed, then such type of orbitals are the Girat orbitals. When center of symmetry is not obeyed, such type of orbitals are called as the ungirat orbitals. So now let us see the shape of the s orbital, d, p and d orbitals. So for s orbital, we are having such type of shape. Here there is a center of symmetry. When we go any one of the direction, we can go the same direction in the opposite way. So we say that the s orbital is Girat. It is Girat orbital. When we study about the p orbital, the shape of the p orbital is dumbbell shape, plus and minus, dumbbell shape. When we go upward, it is plus 1. When we go downward, it is minus 1. So it means that the p orbital is ungirat orbital. And for d orbital, we can say that for the d orbitals, we are having such type of shape. Here it is plus, minus, plus, minus. So when we go from plus on this side, there is plus on the another side, minus on one side, minus on the opposite side. So it is also Girat. Similarly, F is ungirat. So Laporte said that the Girat to ungirat transitions are allowed transitions. Girat to ungirat, these transitions are allowed transitions. Means S to P is allowed, P to D is allowed, D to F is allowed. But for Girat to Girat or Girat to ungirat, those transitions are not allowed. Girat to Girat or ungirat to ungirat, these are not allowed or forbidden. Not allowed or the forbidden. So in this way we can explain the selection rule for the transition of the electrons. Thank you.